configured my calendar here, I neglected to alter the settings such that it's just opened up to the general public. It's so I'm going to change right away and hope that this change going forward is going to propagate or something. I don't know. But before we start, I wanted to kindly ask if one of you could confirm if my audio is fine, if you can hear me just fine, and also if you can see my screen, which I guess you can. I see a thumbs up here, messages. This is very strange here. I have to change everything. In any case, I guess we can start now. I just wanted to make mention of the fact that what I normally do with my classes is, and I'll need to liaise with Iri and Dr. Nyirenda about class participation and attendance, right? So for online sessions, it's not as hectic as the in-person classes that we normally have, or that we're going to be having here. It's an automated process. So if this thing is, it counts towards the marks here, this is me letting you know that there's a heuristic that is going to be used, right? So we just don't look at who has attended. We look at how much of the session actively participated in. So you look at the amount of time you spend in class, if you will. But anyway, I think we can proceed here. So I don't know if this is the correct thing I have. I think it is also. All right. So we had got into a stage, right, when we met last. By the way, before we start, I guess I had reached out to so two things here. First, at least for the time that I'm going to be actively participating in the course, during my portion of the course, we're going to be meeting on Tuesdays at 8. I scheduled on the timetable. On Thursdays at 11. And then we've moved the 9 hours slot, which was on Thursday, to Friday, 12 hours. Now, because securing a venue is usually problematic here, what we're going to be doing on Fridays is we'll be having virtual sessions. So my assumption here is when you specified 12 hours Friday is that everybody who's enrolled in the course is ideally available, right? If not, you need to reach out to the two course representatives so that we sort this issue out. Then also, I'd reached out to the two course reps to find out when over the weekend we needed to have a makeup class for Tuesday. We're supposed to have class on Tuesday. I was told there was no response, and so I've scheduled class for 16 hours on Saturday because you decided not to respond. So that's fine. All right. So we did quite a bit by way of kind of like looking at the admin aspect of the course here, right? And my assumption is that we are all on the same page. Now, I thought we'll just contextualize things here, right? Get some of these things out of the way before we actually start looking at the actual content of the course here. So a bit about the course introduction. You know that if you look around you, what you begin to realize is that data is everywhere these days, right? I mean, just think about the wealth of information that you find on social media, for instance. I would like to think the average person enrolled into this course at one point or the other in a given day will probably find themselves maybe scrolling through social media to see, what people are talking about. Not only that, I would like to think almost everybody who is enrolled in the course has a mobile phone, a mobile device, right? At any given point in time here, you are interacting with your mobile device. You're doing all sorts of funny things on your mobile device, generating data or something. And so data is everywhere. And really, if you look at how people making use of data. And in fact, if we contextualize this from the perspective of Zambia, you begin to notice that there's quite a bit happening, right? So there are certain larger, well-established entities like ZRA, for instance, that have decided to take advantage of these advances as they relate to data mining, if you will, right? So ZRA, in case you were not aware, has set up an AI. I don't know if it's called an AI department or something like that, and they've been doing a number of interesting things here, right? Like for instance, this is one of the things that popped up on their on the Zambia Daily Mail Twitter page or something. And some 2 years ago, ZRA made these ambitious pronouncements. And in fact, this was a pre-era, right, where we've seen everybody talking about AI here, right? So the hype. This was before the hype around AI actually got to the stage it's at right now. Yeah. So in essence, ZRA was working towards trying to detect fraud using AI. What's particularly interesting is that I've actually found myself helping our Center for Information Technologies train people from ZRA. So every year there's I think they call it the business unit that will come through to UNZA for training, mostly on anything to do with data mining and data science, if you will, but quite a bit happening. However, on the flip side, right, what we begin to notice is that there's certain things that we see being thrown around, right? Like data being made available to the general public, which seemingly is really not being effectively and to a certain extent efficiently analyzed, right? So I'll give you an example of what everybody has been talking about in terms of utilization of CDF or constituency development funds, for instance, right? We are dependent on entities like Transparency International Zambia to comb through these reports that are produced. By the way, these reports are actually publicly available, right? Well, I mean, at your own time, I guess you can look up these reports. You don't have to rely on Transparency International Zambia for you to gain a sense of what exactly is happening with CDF funds, CDF utilization. So I mean, you can pretty much just go online and I think there's a CDF report or something. Just do a gov.zm or something and see. So not parliamentary. I think the auditor, the office of the Auditor General is where you find these detailed reports, right? Now, by the time we get to the end of this course, you begin to notice that, well, I think there's quite a bit that we can do by way of taking advantage of data mining techniques, right? To effectively analyze this information. Not only that, go to certain websites, right? Like if you go to parliament.gov.zm, for instance, what you begin to notice is that, I mean, this is where laws are made, right? This is where laws are enacted, in essence. But you begin to notice that there's a lot of important things that are discussed, right, in Parliament. Of course, there are corresponding documents that are made available to the general public. I'm not just talking about acts of Parliament and I don't know where this is coming from here, bills and all those things. I am actually talking about things like Parliament TV, for instance. I'm talking about ministerial statements that are made available, right? At your own time, I do encourage you to find time and go to the publications or try and spend time on the publications pages or menu of the National Assembly of Zambia to gain an appreciation of what I'm talking about. Now, the unfortunate thing about this is that very few people pay particular attention to what is published here, and rightfully so, right? These are usually long documents, things that are not really intuitive to understand. Like if I were you, I would be interested in, because you're going to be taxpayers very, very soon, I'd be interested in finding out how my money is used, right? So instead of you manually going through the yellow book or whatever, what you can do is you can take advantage of data mining techniques ideally, right? So quite a bit of stuff here going on. Now, I also wanted to kind of put it out there to you, in case you are not aware, to make it known to you that government has been taking this issue of AI rather seriously. Okay, and it turns out that as of early this year, the government made available a so-called National Artificial Intelligence Strategy. So, in essence, it's a document that outlines the strategic goals and objectives of government, at least as it relates to how it's going to go about effectively making use of AI to streamline processes in government and other entities, right? Parastatals or something. You probably want to find time and look at this document. I've uploaded it on the Moodle. Um, I kind of have intimate knowledge of this document because myself, along with people like Professor Piri, I think Dr. Lampi as well, were invited to be a part of a team of quote unquote experts who were validating this document, right? And the validation was being done, is it towards the end of last year or something? It took a while for them to make this document available. You notice that the strategy itself supposed to span 2024 all the way up to 2026, but it was only made available in 2025, right? February, somewhere there. Anyway, so there's that. But aside from that, right, what we begin to notice really, at least as it relates to data mining and warehousing, we begin to notice something very interesting. The fact that, derivation of insight is everywhere, right? And I can't really be overemphasized more than when you make reference to the hype around large language models, right? Literally, well, I was going to say literally everybody makes use of large language models, but maybe I'll say, these large language models, especially these chatbots, have seen rapid adoption these last couple of months or so, if you will. But not only that, I'm not really sure what sort of versions of Android you guys use, but we started seeing a manifestation of derivation of insights as it relates to AI on mobile devices, specifically those that are powered by the Android operating system, as early as version 9, right, of Android. I think I'm using version 14 myself. It's frozen, obviously, but on my machine I can't proceed any further. But we see this, right? Not only that, I mean, it's a weird way of making reference to perhaps derivation of insight and stuff, but smart compose, right? So if you're using tools like Google Docs, for instance, you begin to notice that there's a couple of interesting things that have been integrated within these cloud-based services, at least as a result, as they relate to derivation of insights, right? Now, again, more on contextualizing these things, I thought I would again try and speak a bit more about some of the things that I've been a part of. I introduced, I think I spoke about a project that we've been conducting in the Data Lab Research Group, which is tied to, well, at least the name of the project is Road Safety in Zambia or something. So last year we started working towards building models that were going to enable us kind of like help automatically detect potholes. It turns out that the motivation behind doing this is simple. Currently, if you look at your typical road in Zambia, right? And I mean, if you look at your typical road in Zambia, there is, it turns out, there is there's legislation in place, okay, that stipulates which entities are responsible for monitoring and maintaining roads. Okay, now those of you that have spent a great deal of time on, let's say, Google Maps, for instance, will no doubt have come across very weird codes associated to roads, right? So Greatest Road, for instance, is marked as T4 or something. And then if you've driven through roads like Leopard Zero Road, you notice Leopard Zero Road is tagged as D152, for instance, right? It turns out that this is a classification of roads, right? So is it territorial roads, which are T's. These are mostly territorial, terrestrial, territorial, I think. These are roads that will interconnect the Republic with other neighboring countries, ideally, right? So at some point, T4 is going to connect, or it's going to connect into a completely different country or something. And then D is a district road or something. Now, it turns out that there are different entities that are responsible for monitoring and maintaining these roads, right? Like the T's, for instance, are the responsibility of entities like the Road Development Agency. Not like, actually. The Road Development Agency is responsible for maintaining such roads. And then roads that are under the jurisdiction of municipal councils are the responsibility of those municipal councils. Okay, so an example here would be a road like Central Street. I live somewhere near Central Street myself, Chamba Valley, Jesmondin, Chadley area, somewhere there, right? And so RDA, fortunately, is one of those well-resourced entities, right? So if you go to RDA, if you ever get the opportunity to go to RDA, you will probably come across a fleet of vehicles that has, this really weird equipment mounted on them, right? It turns out that they use this equipment. They have other sophisticated equipment, like I think gyroscopes or something. But they'll mount cameras, right? And so routinely they'll drive around these busy roads to capture footage of these roads, right? However, entities like municipal councils and city councils are not as fortunate as RDA. And so what we did last year was in this capstone project report, this is available for those of you that are interested. Really, I worked with these students. What we did last year was we interacted with Lusaka City Council and RDA to find out exactly how they monitor roads. Right? What we discovered was that the techniques that they use, manual in the case of Lusaka City Council, they're time-consuming and quite expensive, really. Right, and so that was a motivation for why we decided to devise this. Now, here's the thing, right? Relative to what we're doing here, for us to build a solution, showcase. Maybe I can kind of quickly demonstrate solution here, right? I have. I'm just going to. I have this video footage here, and what I can do here is maybe just try and see if I can maybe up to 205 or something. So I'm gonna start from 205 or something on the 205 mark, because it takes a while here, right? I just want to run the model, showcase to you exactly how it works, and then maybe Central Street is here, right? I don't know how many of you are familiar with Central Street. It's not very far from Munza. I'd like to think some of you probably live in boarding houses that are somewhere near Chadley and Jesmondin area. Somewhere here is where Nevas Mumba, I guess, stays or something. So I'm going to freeze it until somewhere there's a gashes somewhere here. Probably until I guess 5 or something, right? And then I can see if we can splice it open or something, and then run the model. So the way the model works is quite simple. I'm going to show you exactly how it works just now. I'm just going to go to the folder, and then let's see if I'm going to leave it just here, actually, right? And then I'm just going to splice open this thing here, because it takes and we want to talk about this in evaluation, really, right? It turns out that it takes a while for the model to actually scan through the video footage itself. Ideally, the model takes in it's only as effective if you kind of run images rather than motion pitch on it or something. So I'm just going to say 00. This is 02, 05 or something. And then I'm going to say 2, 00, 05, 00, something like that. It's going to be a lot easier here. And then I'm just going to call this sample, and I'll call this 25 CSC 4792, or this Central Street or something, MP4. So I'm just going to, it's supposed to copy, not copy here. I'm just going to splice it open so that it's a lot easier. So that this thing starts from, it's much smaller actually. By the way, this video footage is coming from my what do you call this? My dash cam. So when I'm driving, I'm constantly capturing video footage, right, of places I'm driving through, and this has actually saved me. Somebody bashed into me not too long ago. I almost died here, but I'm gonna die or another or something. Detect. Almost died here. I was leaving Sababa Drive, connecting into the boulevard here, and somebody just out of nowhere bashed me. And when I went to the police, I used that as proof, right? Say, oh, this guy hit me here. My insurance also. So there's a model, right? This one of the things we're going to be doing. I don't know if it's with me or Professor Piri, but this .pt file is the YOLO model, right? So these kind of students that I was working with decided to use a specific framework, right, for object detection called YOLO. There are a number of them. There's RCNN, for instance, a whole bunch of things. But YOLO happens to be one of those things that people obsess a lot about. So the way this works is quite simple, right? So they built this model, right? You train data set and stuff. You build it in such a way that when you I'm just gonna put it from here. When you run, and I have let's say predict here. I don't know if you know, it says source. Say model is equal to this, and then I'm gonna copy this thing here. Source is this, and then I'm gonna say save. I don't want to save this, but I want to show this, right? So the way this works is when I run, I know what I have missed out here. Let's see here. So save here.
If you type on save.
Yep, thank you. So when I run this, the way our mode actually works is that, and it's going to be a bit slow here. The way it works, not that this is how the final solution kind of works, but the way it works is that as we're passing the motion picture to the model itself, every time, so this model is trained in such a way that if it sees something that looks like a portal, it's going to show you where that portal is with the confidence associated with that prediction, if I can equate that, right? So the numbers you're seeing here, 0.3 or something is the confidence level, right? And in fact, what I'm not sure if I'm the one who's going to do this, but if you use computer vision as a case example, Professor Piri or Dr. Nyirenda, you're going to have a discussion around these numbers, right? Because these are tied to evaluation. So one of the things you can do when you build a model like this is you can say, I'm only interested in filtering things that have detections that have a confidence, interval, a probability. This is a probability score between 0 and 1, right? That are above a certain type of threshold or something, But it turns out that this is not what you are after, is it? What you are after is building something that is going to be useful to whoever is going to be using this. I'm going to cancel this here, it's slow. What you're interested in building is building something that is going to be ultimately useful, like in this particular case, useful to Osaka City Council, right? So what these students did, and if you go to our research group website, you'll find the report is right there. What they did was they built a mapping tool, right? So the way this mapping tool works is it uses input motion picture, so video footage, we used my vehicle, my dash cam in my vehicle. I have tons and tons of video footage. In fact, I've been collecting video footage for a very long time, right? So if you look up at your own time, if you look up, I'm going to go to Capstone publications and Capstone projects here. You want to, if you're interested in getting a sense of what exactly these guys did, you can look up their publication. I'm just going to share it in the info messages here. There we go. It's the link to the publication itself. It has technical details and all those things. But also, in terms of where the data came from, right? Because what you notice very, very soon when we start talking about this is data is crucial to derivation of insights, right? Like when talking about data mining and warehousing, you need data, right? That's the first problem you have got to solve is where is this data going to come from? So in my case, we are fortunate enough because I have this expensive hobby, I want to call it here, but I've been compiling video footage, right, of various, well, mostly Lusaka, but other parts of the country. I have thousands of video footage, right? For instance, I have like, where is that? This is like, where is that? I don't know where it is. 4 hours worth of footage from here until Siavonga or something like that. But anyway, so for this to be useful, what they did was, as part of deployment, they built a mapping tool, right? So the idea behind this application is, on the back end, somebody uses motion pictures input, and then the magic happens in the background. It's time consuming, obviously, but ultimately the output is this mapping tool that showcases to you using map markers and polylines to indicate which roads, for instance, have the most, what do you call this? Have the most potholes and all those things. I was messing around with the application. I was going to demonstrate it here. We're making changes because we're supposed to be presenting this work somewhere. But there's more, right? Other things that we've done here is automatic generation of metadata. So what the UNZA does is it makes available its research output on the so-called institutional repository. So when PhD students and master's students and PhD postgraduate diploma students graduate, their manuscripts are ultimately deposited on the institutional repository. I have no idea if it's up and running. Sometimes bad things happen here. Can't seem to access it. But the problem that's there, and I guess I can use my alma mater or something. The problem that is there is that when these documents are being uploaded, there's auxiliary information that's referred as metadata, right? That is supposed to accompany these documents, so that when people are searching for content, I mean, you have millions and millions of documents on the internet, right? You want to make it a lot easier for people to find what it is they're looking for. So if I'm searching for, I'm looking for work that was supervised by a PhD manuscript that was supervised by Professor Piri, I want to be able to find that information. The problem that is there with the UNZA is that information is not comprehensively described. I don't know what's happening here. Most of the things are fading here. It's a bit weird here. Information is not, UNZA repository is down. How sad, depressing. My alma mater is the institutional repository is not really working the way it ought to be. I guess I can use some random example or something. I just go to PhD and just open up one of the most recent ones. So the idea behind this information is you have this auxiliary or data about data called metadata, which is supposed to be used to tag this information, right? And it turns out that there's quite a number of metadata elements, right? Contributor details, right? The abstract, the subjects, the institution, the department associated with that manuscript or something. The ones that doesn't do a lot of this stuff, right? Now, because they don't do a lot of this stuff, it becomes difficult to find the information. In fact, there's a method to the madness here. It turns out that one of the things we are doing is we are trying to build a portal. I don't know if the portal is up and running here, but we're building a portal. So the way the portal is supposed to work is going to be putting master's manuscripts, doctoral manuscripts from all the different universities in Zambia, and then kind of like make them available in a centralized location. Now, for us to be able to do that, we need this metadata. So what we're doing in this project is trying to solve the simple issue of the fact that important metadata associated with the supervisors or advisors of that master's student or or PhD student is missing. So if you go to the UNZA repository, you will not find these tags here. Like in this particular case, for my alma mater, this is University of Cape Town, there's advisor details. The author here is the student themselves. So what we did was we took advantage of natural language generation, right? And there's a whole dissertation centered around this. If you want details about how this works, I worked with fourth year students who, I mean, we're using SPACE, which is a natural language. It's a natural language processing library, if you will. It's in the same family as JSIM and NLTK, which I guess some of you have probably looked at length. But details of what we did are available in this capstone project report that was done in 2022. I'm going to share this as well. You don't have to read the entire document, but maybe just scan through, I guess, the introduction and the results and the evaluation or something like that. So the way this works is simple, right? What we discovered is that for your typical manuscript at UNZA, the information we're looking for is found in a single source of truth, the actual PDF document, buried in some of the preliminary pages. And we discovered that the best place to find advisor details is the acknowledgement page. So what these guys were doing, or what we were doing in this project in terms of data, that's what you want to focus on here for you to understand what we're talking about, right? Where's the data coming from and what were we doing? So in terms of the data, what we were doing is we get a dissertation. And I want to use my alma mater here as an example, although the manuscript itself, the manuscript itself is formatted different. So at the UNZA, manuscripts are formatted based on guidelines. So the UNZA has come up with guidelines. Docs. The UNZA has guidelines on how manuscripts should be prepared, right? This document is available for public consumption on the graduate.unza.zm website. Now, part of what those guidelines says, unfortunately, they don't say whether you should include supervisor details. For my alma mater, right? Like you'd have details like, oh, the advisors or supervisors are on the title page. However, for UNZA, because the guidelines do not indicate that you should add the supervisor details here, what they do is this, by the way. They tell you that the cover page should be like this. Come on. Like this. So on the title page, you just have the title, then your name, a statement, and just the University of Zambia. Like, that's it. No supervisor details. But what we discovered when we did our business understanding exercise, and this will make sense because we're going to look at the various stages of data mining, right? We discovered that this information is buried deep in the acknowledgement section. Almost each and every student will have this sort of section, a page. And on this page, you will have interesting things like this, right? This. Statements, so sentences that will hint at the fact that in this sentence, you'll find the names of supervisors. Okay? Right? If you look at this, there's this sentence as well. I am deeply grateful to Hussein Suleiman for supervising this thesis. So what these guys started doing here is taking advantage of a technique within NLP called named entity recognition. So when you're passing through textual content, you can identify names or entity names, names of people, names of things or something. And this is what this page is showcasing. It's showcasing that this Dr. Jackson Peary, it's identified Jackson Peary as a person, right? The Department of Computer Science as it's an entity, but it's an organization. FAO is an organization. So this is what these guys were doing, right? they essentially built a solution that was able to identify entities, and specific entities were interested in filtering names of people. In addition, supervisors, right? So if you read the document here, you figure out what this was. So the question is, well, how are you extracting the data? It's quite simple, right? If you have this long document, hundreds of pages long, you get it, and you identify where the acknowledgement page is in your PDF document. And these guys, I think towards the end, they were running out of time, so they used like a very brute force heuristic, right? Where you're passing through a document and my other connection won't. I do apologize for that. I just lost my connection on Liquid. Can be a mess sometimes. So what the heuristic was simple, right? You're passing through this document because you're interested in mining this page here. Now, if you notice at the top, this page 5 of 214 or something. So it's like, well, if this is where my acknowledgement page is, what I can do is I can use like fancy tools like PDFTK or something, right? And say, get this document, right? And get page number 5. So it's like 505. And then just send this as sample. I'm going to call this CSC 4792 or something .pdf. Acknowledgements page or something, right? So you splice this open. When you splice this, when you extract this page here, you can then convert this to text, right? So again, you can use tools like PDF to text, and of course there are libraries that you can use here, right? Just say let this document to text, and then lo and behold, you're going to have this thing here, this document, right? And now that you have text, you can then do fancy things with this text, right? So obviously your algorithms are not really, some algorithms are not really going to work with raw text, so you've got to preprocess it, which is why we'll have to learn how to process this content or something, right? You learn how to process data, you clean it up and all those things, right? And then you're using this now as input to identify names of things. Yeah, so we did that, and we've done quite a number of other things, right? Like for instance, classification of these ETDs, right? So there's this notion that an entity like UNZA will produce a lot of different types of documents. Final year student reports, master's dissertations, PhD theses, journal articles, right? Now, because things are not properly organized at the UNZA, some of the things we've been doing is working towards how best we can identify classes that these documents are associated with, right? So we were actually doing a whole bunch of things here. I don't know if I'll be able to access our IPMH protocol here, but we are harvesting information using protocols like the OIPMH protocol, for instance, to help with the labeling of the data, because this is classic machine learning, supervised machine learning here, right? So you have got to, you collect the data, you label it, and all those things. All right. And then I think I'd mentioned that some of the other things that we've done is we've built. If you remember, I introduced this I guess I'll call this machine learning model, which tells you, it's a binary classifier. Is this person more likely to fail? Yes or no, right? the way we built that, right? It sounds like it's trivial here, but the way this thing is built is it's built in such a way, it's again supervised machine learning, built in such a way that you have, I don't know where this is. So you have, yeah, I have it here. You collect data, you find data, right? This is rooted in evidence, by the way. It's like, I don't know if I'll be able to find this. What you do is you open this up so that you see. For you to build this solution, right? You first of all start by understanding what makes, this is what we did anyway, what contributes towards student performance, student learning outcomes. So as part of business understanding, we realized that there were a whole range of things. There's a whole dissertation, a whole report, by the way. I worked with students as well. If you're trying to understand this, again, go to here and specifically look at what these guys did in 2021, 4 years ago. There's a whole report about what they did, systematic and methodical like that, including the evaluation and stuff. So what we discovered was that performance for students, at least in this particular course, is dependent on whether they are engaged, right? So it's engagement. It was their workload. So in terms of engagement, like right now, there are some people that are not engaging with this course, right? I'm counting 78 people that 78 minus myself and my shared screen. So there's just 76 of you. We can assume that you are engaging because you're attending classes, right? This is how we measure the engagement. If you're wondering, how to what extent are you really actively participating in the course? And the way we are doing is, the way we've been doing this is we're looking at things like attendance, but also we're looking at the logs, Moodle logs. It's a bit weird here, but Moodle logs, right? So it's like when you go to Moodle, I've already seen some of you are not engaging in the course, I guess. When you go to Moodle, right, we said we're going to measure engagement by seeing to what extent people access specific features on the Moodle. So you may not have access to this feature, but I do myself. I have access to logs. So if I go to Moodle, I can have a sense of to what extent people are engaging. So Jacob, for instance, Jacob Monga, logged on somewhere around 12:26, and he downloaded lecture 1, for instance. But the way we're doing this is looking at different things that students are doing here, right? So there's engagement, there's things like course workload, right? A whole range of other things, the demographic factors as well, right? So in terms of course workload, how many courses are you enrolled into? The thinking here is if you have a lot of courses, then you're going to perform poorly here, right? So long story short is the so-called features or the things that we were mining for were ultimately, as part of data preprocessing or something, we merged the different sort of data sources and came up with this vector, right? Each student, by the way, these are masked for ethical consideration is crucial here, right? So these are fictitious names. We got the student IDs, hashed them, and then the names were actually changed as well. So we're compiling things like we gained access to your age or something. You can infer the age, right? If you have a date of birth, gender, your minor courses, whether you're funded or not, or something like that, right? What else? We did a survey, right? We do a survey asking questions like, where are you originally from, right? The thinking here is if you are from a certain part, a remote part of the country, maybe you perform poorly in first year or something because you may not have had access to a lot of resources, right? Motivation for doing this course or something. So you notice here we're capturing a whole range of things here, important information. These are called features, right? Course workload, Moodle hits and stuff. And then ultimately, we are trying to see if there's a correlation between some of these factors and your performance in the assessments, the quizzes, the tests, and the final exam. So it's like it's like you would say, well, do we see a correlation between, here's something that you guys can easily relate to, right? Is there a correlation between somebody, where is that? Somebody being accommodated or not. I don't know if it's here somewhere. Here. Do we see a pattern where performance is to a certain extent determined by whether somebody is accommodated or not? By the way, we have seen this, right, in the first years. And it's not like we are saying because you are not accommodated is the reason why you are not performing better than you should. That's not the goal of data mining, is it? The interpretation of the results may not be your responsibility. The reason could be that because you're not accommodated, you stay 2 hours away, and so you're spending an hour commuting or something like that, or you don't have access to the library and all those things. You may not be accommodated, but maybe you live close by. But anyways, causation versus correlation, is it? Is what we're talking about here, right? So we mined a lot of. You may not appreciate this right now, but in terms of where we were mining this information, the source of data, right? The data sources. The course instructor meticulously collect scores for all assessments, right? And in this course, is computer architecture, right? Computer systems and architecture. It's a difficult course here. We have details of like quiz scores for all the students dating back 2018 or something like that, right? So it's like assessment results. We have things like Moodle logs, right? So these things here we mine. For a typical academic year, you are mining everything here. By the way, this is so rich. You can figure out who is accessing this using a mobile app, and all those things. Who is on campus, right, and stuff. Who is not on campus, and all those things. You can tell, right, who is accessing this using eduroam and all those things. What are they doing when they access this Moodle site? How are they engaging? Well, somebody downloaded this document, right? Where is that? There's a document, the AI thing here. But anyways, so Moodle logs. What else? Well, we got permission and we were harvesting things from SIS. So this data you are seeing here is mined from SIS. These things here, right? What else? All of these things you're seeing here, these are mined from SIS. Like we would know how old you are or something from SIS, right? It would be interesting to see what sort of factors would influence performance in this course, right? At fourth year, because it says at first year. The things that affect performance at first year are not exactly the same at fourth year. These are different programs, different courses as well. Anyways, so we did this, right? This course. And then again, I mentioned we are working towards like Wikipedia. I thought would also highlight where we're harvesting this data from. Details of what we did or what we've been doing as part of this project or something else we did is available in, there's a capstone project report as well. So we have students that did a bit of interesting mining, right? Before last year. We did so, they did some really interesting work such that we actually published work based on this in conference proceedings, right? So part of their work was extended and we published Psychsit. So I'm going to share this in case you're interested. What these guys were doing, part of what we're doing is they were interested in quantifying, right? I'm going to showcase something to you here. They were interested in quantifying Psychsit. They were interested in quantifying to what extent do people contribute content, do Zambians contribute content on Wikipedia? Now, if you think about this, right, it's a hard problem, or maybe not really hard here. But we figured out that one of the things we're going to do here is we're going to say we're going to harvest the version history of all Zambia-centric pages. There's an API, by the way. You don't have to worry about, oh, but how are you doing this? So we're going to Wikipedia, and then we go to the history of the page, and we're harvesting these checkpoints, right? Every time there's a change on Wikipedia, it's versioned. If you notice this, it's versioned, right? Who did this? If it's a logged on user, if it's an anonymous user, which IP address was used? So there was a whole bunch of interesting mining and some interesting findings here, right? This, right? You have the Zambia page. If you look at the Zambia page, you notice that in terms of where those changes are coming from, we see that top on the list of people that uh, are editing this Zambia page are from the US, right? Shame on us. Somebody else is writing your history here. If you look at pages like the Victoria Falls, Zambia is not even on the top 10 list of countries where the edits are coming from, right? Anyways, so for us to come up with these conclusions, right, these nice maps here, we were mining information from here. Yeah. A lot of interesting things being done behind the scenes here, right? And then, something else we've been doing, I think I mentioned, is we are we are working on this project with people from the invest teaching hospitals, um, and in terms of data we are mining from here. Besides the images themselves, pixel representation of the images, something we are doing is we are getting metadata elements, right, from the image itself, if that makes sense. Um, so if you look at your typical DICOM image, it turns out that I'm trying to see if I can find. I want to print. I'm trying to see if I can print out DICOM metadata or something. I don't know if I'll be able to do this. I normally have. I haven't cleaned up my computer this year, so I normally have these things somewhere, right? They're usually somewhere here. I don't know if they'll be here. I don't know if I'll be able to find.
Sorry to disturb, but the systems stream has a class
Oh,
13.
okay.
Yes.
Where is the class going to be here?
Uh,
Okay. We're going to continue here and transition to the next lecture session because there's a short thing. Can I not wrap up? It's just 2 minutes. Let's finish this. I've noted that they have a class here. All right. So the long and short of it here is that if you think about everything here, what's central to everything is data, right? And it turns out that there's different types of data: images, audio, like sound, right? If you're wanting to take advantage of like speech synthesis and all those things, there's text, you know. Um, if you want, you can argue, say, oh, there's video, but really video is nothing, is composed of images, right? So data is central, and this is why we are interested in learning about how to mine data ideally, right? These slides here are just showcasing an interesting report from Oxford Insights called the Government AI Readiness Index. It kind of showcases some of the things you've got to take into account. So just because we are looking at the technical aspect of things doesn't necessarily mean that that's the only thing that's there. There's other things that you have got to take into account here. And what you notice in lecture series number 3, I think it is that if you look at the different phases of data mining, for instance, you notice that the most time-consuming part and difficult part is the part where you're preparing the data, not implementing the solution, right? And you soon understand why this is the case here. And so what you're going to do with me here is we're going to work towards mostly these things that are highlighted in red. And I want to start off here by looking at a little bit of Python. We're going to cruise through this because I'm told you've already been taught how to program in Python. So we're going to focus really on the core libraries, if you will. And then afterwards, we'll study the knowledge discovery and data mining process. We're going to use the CRISP DM methodology or model or approach. It has 6 distinct phases. You notice that I was speaking to things like, business understanding, evaluation, deployment, right? So we'll discuss all of these different phases. And then we'll have a dedicated session where we'll look at how we clean the data and how we transform it ideally. All the while, we'll be looking at other important topics like exploratory data analysis, for instance, right? And then I don't know if I'm going to be the one who's going to look at model implementation, but if I am, we're going to look at classification and clustering. And then that's it. So listen, I don't think there's questions here, but I will see you tomorrow at 16 hours virtually, where we shall start our discussion of lecture series number 2. Okay, I'm going to upload number 2 so that you already have access to it, but it's just going to be I guess a repeat of Python programming with a focus on some of the things we're going to be using. All right, I'm going to pause here and excuse those that have class, but I'm going to remain for a few minutes in case those that are going to be around have questions. Please, there's a hand up from David. Hey, listen, I teach this course, I teach this very course, right? On, what do you call this? I teach this very course at master's level, right? And one of the things I do here is I don't know why that is here, but one of the things I do is I collect interesting metrics here as they relate to. I hope this thing was working, right? I collect interesting metrics like I want to show you something. This, right? So in each session, I will compile individuals that have attended class. Now, because some of you are logging in using your using your personal email accounts and stuff, and not your own assigned email addresses, it'll be difficult for me to match these names to your computer number. So I'll put together a spreadsheet, and I'll ask you, right? We'll crowdsource this activity. I'll ask you to assign to indicate your student ID. So if you are Farai, for instance, you need to indicate your computer number so that we know who is, right? I always experiment with these things. It's part of data mining as well, right? All right. So there's a question from, I think there's a hand up. I don't know if it was a mistake, but yes. I thought that was a question. No question. Okay. Does this course have a course outline? Yes. It's a course outline. It's on the Moodle, right? I uploaded it on the Moodle, but also Professor Piri shared it in the WhatsApp group. So if you go on the Moodle and you scroll down here, under supplementary material, you'll notice that there's this document called CSC 4792 syllabus. This document has this, right? Each course at UNZA has a course outline. There we go. Sir, what is going on? I'm lost. Well, we're having Katrina. We're having class. Okay. I don't have any other questions. Okay. Don't worry about getting lost right now. We're just getting started. I hope you won't really. No, I'm sure you will be on the same page very, very soon. Good. Thank you. If there are no questions, I will see you tomorrow. We have class at 16 hours. Goodbye. Thank you.